Hi friend, welcome to the Pure Mathematics lecture. It is pre-algebra class, lecture 25. Title of this lecture is Generalization about n root of a number. Here is some rule. We want to explain that real number, integer, roots of a. Example. Here, if a radical is greater than 0, it is positive, then n greater than 0 is even integer, n root of a minus n root of a. Example, they all exist, they are real number, they are the root of this number all exist. Fourth root of 81 is equal to 3 minus fourth root of 81 is equal to minus 3. If a is greater than 0 or a is less than 0, both positive or negative, n is odd number, then there exists a root of a, n root of a, n root of a, n third root, example, third root of minus 8 is equal to minus 2, third root of 8 is equal to 2. This number, this is, they are important, minus 8, they are, it is positive, minus, negative, but the index is odd number, then it is equal to minus 2. The third root of minus 8 exists, it is equal to minus 2. Third root of 8 is equal to 2. It is positive, it is equal to plus 2. Actually, if this is positive or negative, no problem, merely a number which a can be. Here, if n is odd number, then n is odd number, the n root of a exists like this, as you see. If a is less than 0, but n is even integer, this n is even integer, a is negative, square root of minus 4. Here the index is even integer, even, it is equal to 2. Therefore, square root of minus 4 is not real number. There does not exist any real number. We will not find such real number which be the root of a, n root of a. If n is even integer, a less than 0, negative. If n is even integer, then there is no real number as root of a, n root of a. Example, square root of minus 4 is not a real number. Similarly, sixth root of minus 10 is not a real number, because we cannot find any real number such that multiply by itself 6 times, then we get minus 10, then produce minus 10. It is impossible. Therefore, it is not a real number. Similarly, if a is equal to 0, n is even or odd, then n root of 0 is equal to 0, 5 root of 0 is equal to 0, 20 root of 0 is equal to 0. Similarly, we can see like that. It was the concept of n root of a real number, generalization about n root of a number. If a is greater than 0, n is greater than 0 is even integer, then this thing, the root of this expression exists. This 4 root of 81 is equal to 3 minus 4 root of 81 is equal to minus 3. A is positive or negative, both. N is odd number, then the root of this number exists. Third root of minus 8 is equal to minus 2. Third root of 8 is equal to 2. If a is less than 0, negative, then n is even integer. We cannot find real numbers such that, like that. Square root of minus 4 is not a real number. A is equal to 0, n is even integer, even or odd integer, both. We can, the n root of 0 is equal to 0. Integers 1, 4, 9, 16, 25 and 36 are called perfect squares because we can find a number, an integer, which multiply by itself 2 times, then produce the above numbers. Integers 1, 8, 27, 64 and 81 are called cubes because there exists a real number, and there exists an integer such that multiply 3 times with itself by itself produce the above integers. Here we want to explain about the square root of perfect squares and cubes, perfect cubes. It's called perfect cubes. Perfect cubes. The square root of 1 is equal to 1 because 1 is equal to 1 square. The square root of 4 is equal to 2 because 4 is equal to 2 square. The square root of 9 is equal to 3 because 9 is equal to 3 square. The square root of 16 is equal to 4 because 16 is equal to 4 square. 16, 14. 16, 36 is equal to 25. Is equal to 5 because 25 is equal to 5 square. The square root of 36 is equal to 6 because 36 is equal to 6 square. square root of 49 is equal to 7 because 49 is equal to 7 square, and so on. Similarly, here we said that one square integers 1, 4, 9, 6, 25 and 36 has they are called perfect square because every one of them has a number. We can find any number which, if we multiply 2 times by itself, they give 1, 4, 9, 6, 25 and so on up to 36. For example, if we consider 36, the square root of 36 is 6 because 6 is, if multiplied 2 times by itself, it will give us 36. Similarly, integers 1, 8, 27, 64 and 81 are called perfect squares because there exist an integers. If we multiply 3 times by itself, it will give us these numbers 1 up to 81. We want to write also here cube root of 1 is equal to 1 because one is equal to 1 cube. Square root of cube root of 8 is equal to 2 because 8 is equal to 2 to the power 3. Cube root of 27 is equal to 3 because 27 is equal to 3 to the power 3. Cube root of 64 is equal to 4 because 64 is equal to 4 to the power 3. Cube root of 125 is equal to 5 because 125 is equal to 5 square. Cube root of 216 is equal to 6 because 216 is equal to 5 to the power 6 to the power 3 and so on. Already we told you square root of third root of minus 8 is equal to minus 2 because minus 2 whole to the power 3 is equal to minus 8. This number should rise 3 times to the power 3 times, then it should be equal the product of minus 2 whole to the power 3 should produce minus 3. It is correct. But consider this square root of minus 8 is not real number. Is not real number because we cannot find any real number which multiply 4 times then give us minus 8, or the its product should be minus 8. Because for this reason we say that it is not a real number. It was the lesson of this lecture 25, generalization about n root of a number, which we explain these things here. Thank you.